Hey guys, we are back. We got another topic. So, again, these are kind of smaller topics that we're just doing kind of one at a time. Um, the one we're looking at today kind of goes back to some stuff we were doing first semester with, we called them zeros or roots. And remember, the zeros or the roots was where the graph crossed the x-axis. If you remember that, remember the x-axis right here. The roots or the zeros wherever the graph crosses the x-axis. Okay. Now the thing we didn't really get into is there are some special roots depending on the graph. Now this is the one we did normally right here. So this is crossing. Remember, that's crossing. Let's say that that's at like -6. Okay, then that's crossing right there at -6. Okay. Now, because that's crossing at -6, that's going to be just one root. Now remember, guys, the x-intercept, again, -6, remember, actually comes from setting x plus 6 equal to 0. Remember how we did this? So we take the parentheses, set it equal to 0. I have to -6, -6. So actually the answer is -6 because I had to solve it. So remember, when you actually see, okay, that's at -6, in the binomial, it's actually positive. Okay? Remember, I mean, we're just kind of working backwards on some of this. Okay, now here's the part that's kind of new here. Okay, this right here is where the graph is coming down and touching. That is an x-intercept, but it's a special one because it's touching and going back up. So this one, let's say that's at -1, has something called multiplicity, which means it has more than one solution. So because it comes down and touches and goes back up, there's actually more than one answer there. Now, what's nice is it's still the same idea. Since that's since that's -1, then actually what it comes from is the binomial of +1. So guys, remember, so the -6 makes +6, the -1 makes +1. But again, because it's multiplicity means it's going to have some exponent here. Now, here's the thing. Looking at the picture, we don't know. Now, in higher math, we'll actually solve some things. But let's just say that that was squared. So multiplicity means more than one. So it could be squared, it could be cubed. I mean, this could be any power. So when it comes down and touches, it has any power right there. Okay? Now, this right here, see how it curves, but it isn't actually touching? Okay, guys, this is an imaginary solution. Now, this should kind of come back to you. Remember when we were solving things and we got the letter I? Remember how we got the letter I? What did we have? We had a negative square root. So basically, if I know that this is, let's say that this is at 3. Let's say this right here is at 3. Right here, up from 3 right there. Then actually what I have is a binomial that's actually going to have to be at a negative. Because watch, when I solve this, now see the difference? The square is on the x. Here the square was on the binomial. So I had that answer twice. But here, just like we did, remember all these binomials can be set equal to 0. If I -3, I get x squared. 0 minus 3 is a -3. And then remember, to get rid of square, we square root. And remember, this was when we had to bring out the letter I. Remember? When you have a negative square root, we had to bring out the letter I, and then that radical, the square root, went back to a positive. So anyway, guys, this, when we see the graph turn, but it doesn't actually cross, that's an imaginary number, and you're going to see it with a squared binomial with a square inside that would actually become an imaginary number. Okay. Last one. Now this would, let's say that this is like an 8 right here. Now again, because it comes down and touches again, that has another multiplicity, and that's a positive 8. So in the binomial, it's going to be a negative 8. And again, because it touches multiplicity, okay, let's just say that it's like a power 4. I don't know. Again, any multiplicity can be like a power 2. This was multiplicity. This is multiplicity. It could be a power 4, power 3, power 5. I mean, it doesn't really matter too much unless they tell you how many roots there are, how many solutions there are, which, again, those that go on to pre-calc, we'll do more with this next year. But guys, in general, we're trying to say, what are the different x-intercepts? Now, again, I wanted to show you a picture, but we're not going to actually have a picture on these. We're going to just have the parentheses that are being factored out. So let's actually do one. And guys, hopefully this is not going to be too difficult. So look at this problem here. So again, the directions are going to say find the x-intercepts. Okay. Now we have x plus 4 with a power 3. Guys, that means that's a multiplicity. So I have this binomial 3 times, but guys, it doesn't matter if I have it 3 times, because if I solve this, remember, I'm going to take that binomial, set it equal to 0, solve. Okay, I have x equals negative 4. Okay, now I'm going to do a little multiplicity. That's short for multiplicity, but I have multiplicity 3. So my first answer, I have x equals negative 4, because that binomial set equal to 0 makes a negative 4, but I have it 3 times. Okay, now look, if you remember from the other side, the square is not on the outside, it's on the inside. So again, if I set this equal to 0 and solve, 0 minus 2 is a negative 2. Remember to get rid of square, we square root. Uh-oh, negative square root. We're not allowed to have that. So remember, that's when we pull out the letter I with the radical 2. Okay, and that is the answer right there. I radical 2. And that's that actually does not cross. That's not an x-intercept. Okay, that doesn't cross. So when you get the letter I, it actually is no x-intercept because it doesn't cross. Remember back from over here, when you get an imaginary number, it's looping up above the x-axis. I don't actually cross when I have an imaginary number. So find the x-intercepts. Okay, this is actually not an x-intercept, okay? Any letter I would not consider that. Okay, the next binomial, okay, is just x minus 1. Now there's no multiplicity here, so actually I just solve it like normal. And there's my answer. I mean, I have that. So that would actually cross if we go back to this one. So the graph, if I drew that graph, it would cross straight over at positive 1 here, but it would go straight through. It wouldn't bounce. Remember, the bouncing ones that bounce off the graph, that's when you get multiplicity. Okay? But when it crosses over, okay, it doesn't have multiplicity. So this would be one that would just cross over. Okay, the last one, and again, this is really not that hard of math. You just got to understand what they're giving you. Since it's x minus 3, okay, set that equal to 0, x plus 3. So the next one is positive 3 with multiplicity 2. See that power 2 there? And that's it. Okay. So again, x plus 4 to the third power. I take x plus 4, set it equal to 0, solve. Okay, the positive 4 becomes a minus 4, so x equals negative 4, but multiplicity 3. Okay, now this one, because the square is inside, when I solve with the square, I get an I, so that actually is not an x-intercept at all. That doesn't cross at all. This one doesn't have a power, so I solve it. That's just an answer by itself. Okay, this one, I solve it, but I have a power 2 up here. So that power 2 on the outside makes a multiplicity 2. Okay, and this would be my answer. Those would be my x-intercepts. Okay, I know it's a little weird. I mean, maybe you'll have to watch this video more than once. Okay, Again, on the exam, it's multiple choice and you're just picking out the answers. I don't think it's going to be that hard. Okay, so here is your assignment. Find the x-intercepts. Okay, you got x plus 2, parenthesis squared, parenthesis x squared plus 1, parenthesis, and then x minus 5, parenthesis 3. Okay, so go ahead and try those. Put that into the journal post, and you'll get credit. Okay, see you guys. Bye.